Okay, we
have
have
some
some
examples
of
of
vector space
vector space
as a space.
as a space.
Okay,
Okay.
uh,
Uh,
we have
we have
the linear
the
system,
linear systems,
right? We have the linear
right? We have the
system,
linear systems.
A, B, C, D.
A, B, C, D.
Okay.
Okay.
This one
This
like
one like
linear
homogeneous
system
linear system
because
because
all constant
all
terms
constant terms
are zeros,
are
right?
zeros, right?
Yeah.
Yeah.
So when
So
we
when we
apply
apply
Gaussian
the Gaussian
elimination or
elimination or
Gauss-Jordan elimination,
Gauss-Jordan
for
elimination,
example,
okay, for example,
question A,
so question
okay,
A,
we can
okay,
get the
we can
solution,
get the
right?
solution,
Solution.
right? The solution.
Yeah.
Yeah.
So for the
So
solution,
for the solution, you can say we have three
we have three
variable y
three
and
variable
three variable
z.
z.
For example, if
For example, if
y
y
as and
as
z
and
a
z a
t, you
t,
can x
you
a
can
you can
x
get
a
x
you can
a
get
to
x a
2s
to
minus
2s minus
3t.
3t.
So if we
So if
indicate the
we indicate
vectors,
the
solution
vectors,
vectors,
solution
we have x,
vectors, we have x,
y is
y is
equal
x
to what?
equal to what?
2s minus
2s minus
3t.
3t.
S and
S and
right?
t, right?
Then if I take
And
s
then if I
outside,
take s
you can
outside,
get what? 1,
you
3,
can get
2,
what? 1,
1,
3,
0.
2,
Okay?
1,
And t
0.
outside, we
Okay?
can get
And
what?
t outside,
Minus
we
3,
can get what?
0,
Minus
1.
3, 0, 1.
Right?
Right?
Okay?
Okay?
Yeah.
Yeah.
This one is S.
This one is S.
This one is.
This one is T.
Yeah.
Yeah.
So
So if we
we
say
have
we
this
have
vector
this
space,
vector
right?
space,
The
right?
vector
The
space
vector
mean the solution
space
space
mean the
because S
solution
and T
space
is random.
because S and
S
T
and T
is
belong
random.
to real
S and
number.
T belong to real number.
Okay, so we don't
Okay,
know
so we don't know
S
for
certain
S
S or
certain S
certain T,
or certain T,
but we know
but we know
any S and
any
T
S
we can
and
get
T
the
we can
solution
get the
space,
solution
right?
space, right?
Solution space.
Solution space.
Solution space.
Solution space.
Yeah. So solution
So
space
solution
or
space
vector
or
space
a vector
of the
space
solution.
of the solution.
Okay.
Okay.
Yeah. We can
We
say
can
we
say
have
we
a vector
have a
space
vector
of
space of
all solutions
all
with S
solutions
and
with
T,
S and
or we
T,
say
or we
solution
say
space.
solution space.
Yeah.
Yeah.
Sometimes we say
Sometimes
null
we say
space.
null
Okay.
space. Okay.
Yeah.
Yeah.
So here we
So
have
here we
two
have two
variables. So
variables.
that
So
means
that
this one
means this
lie
one
a
lie
plane,
a
right?
plane, right? A plane.
Yeah.
Yeah.
So this
So this
is the
is
equation
the
of a
equation
plane,
of
right?
a
Through
plane,
the
right?
origin.
Through the
That
origin.
case one
That's
minus
H
two,
1
three
minus
is a
2
normal, right?
3
This one,
is a
right?
normal, right?
This
This
one.
one, right? This one.
Yeah. So
Yeah.
we have
So we have
LYAS and
LYAS and
ZAT. So that means
ZAT.
you
So
get
that
X
means you get
equal
X
to
is
Y
to
minus
Y minus
3Z. Or we
3Z.
can
Or
say
we
X
can say
minus
X minus
2Y
2Y
plus 3Z
plus
is 0.
3Z is 0.
Okay.
Okay. Yeah.
So this one is
So this one
R3.
is
Vector
R3.
space is
Vector
R3.
space is R3.
The
Okay.
solution
The
space is
solution
R3.
space is R3.
And
And
similarly,
similarly, we have
the answers
the
of
answers of
question
such
B.
question B.
Okay,
Okay,
we can get
we can
x
get
is
x
minus
is minus
5t,
5t,
y is minus
y
3
is
is
minus t
exactly
is
t.
exactly
So
t. So
we have this
we have
space
this
of
space
solution
of
space
solution
is
space
line
is the line.
because we only
Okay,
have
because we only have
one variable.
one variable. Okay,
And here
and
for
here
solution
for solutions
the
for
question
such
C,
questions
we have x
C,
is
we have
0,
x is
y is
0,
0,
y
and
is
z
0,
is
and
0.
z is 0.
So that
So
means
that
we have
means we have
0 subspace, only
zero
one vector,
subspace, only
right?
one vector
And
is
for
0,
subscription
right?
D,
And for such question D,
so
okay,
this
so
is random for x, y.
it's
That's because
random
this
for
is
x,
zero
y, just
matrix,
because this is zero
right? It's zero
matrices,
matrix. So
right? This is
the
zero matrix.
solution
So
space
the
is
solution
R3
space A are 3
because
because
any vectors
any vectors
will satisfy
this linear system.
So
Okay,
we say
so
the
we say the solution
R3.
space is R3.
The solution
The solution space of question A is a plane. The solution space of question B is a line, and the solution space of
question
question C is
0.
zero. Okay, zero vectors. Okay.
Look at this one.
Look at this one.
We have
the vector space, right?
The
vector space will be R2
because
we have two dimension x
vector space
and y.
And
It's a vector
the
space.
question is,
And the question is
to determine
whether each subset is a subspace of R2 or not. So now, if we consider this one x plus 2y is 0, that means
this line.
So this line goes through the origins.
Okay,
So this one is
the space.
Okay. Sorry.
Hello.
Ok, để đợi để gọi người nhà xuống lấy.
Okay, so
and then we have
another line.
X plus 2y is 1. Okay.
This is the line.
But this line doesn't go through. Okay, doesn't go through the origins. So here is not subspace.
Okay.
So
if we follow
the theory, we have
the
subspace
of
x plus 2y to be 0. Okay. Yeah.
This one. Vector space
is R2
because we have
x axis, y axis. So vector space is R2.
Now
we have the subset
consisting of
on both
this circle.
This circle, right? This circles.
We have
x square plus 2y square is 1. This circle. Okay.
So
this subset is not a subspace. Why?
Because
if we just pick up 2 points, 1, 0 and 0, 1. Okay. So if we have x1 and y1 is 1, 0.
And
x2 and y2 is 0, 1. Okay.
So when we
take the sum, so this one I say the vector u, here is vector v. So when we take u plus v is what? 1, 0 plus 0, 1, you get 1, 1.
So
if you have 1, 1,
the
result vector is outside of the circle.
So
SM1 is not satisfied.
Right?
SM1 talk about what? U plus v should belong to W and V.
Okay.
So U plus V is 1, 1. So 1, 1 belong to vector space V, but doesn't belong to subset W.
Okay.
So
this subset
is not a subspace.
Okay.
Yes.
Just
remind you if we have the vector space R2.
Okay.
So we have a 0 subspace.
We have
the line
goes through
the origins, or we have itself.
They are all
subspaces of vector space R2. Okay. Yeah.
Now we
have vector space R3. Okay.
We just
consider a plane, right?
So if we consider
this plane
is
those and pass through the origins,
right? So this one is not subspace.
So this one
In not subspace.
in not
But for this one, the planes bar through the origin. So this is subspace. This is subspace.
But for this subspace.
Okay.
This is subspace. Okay.
So you should
remember that I will not follow
any one textbook.
I give you many
different textbooks.
Some slides I pick up from
one textbook.
Another slides
coming from
another textbooks.
Okay, it depends
on my feeling.
If I think
it's good for you, I add
into my
lectures.
Okay. So
when you
read
my lecture at home,
try
to
consider different
textbooks.
Okay. Try to read
textbooks.
And then
you can get your observation for yourself. Okay.
Understand?
Yeah.
And then
some students comment me why.
No answer.
It depends on my experience.
If I think
it's good,
I do it. Okay. So if you don't like to study,
so if you don't like to study with me, you study with another lecturer. Understand?
Okay. Anyway, it's just good
for you.
Yeah. So when you read
many textbooks, you can get
many
viewpoints.
Okay, and then
you get the observation for yourself, the knowledge for yourself.
Not mine.
Okay. Yeah.
You are
VGU student. Okay, you need to study
a lot.
You know.
In the same year,
many thousand students
to study
ECE.
Then
if you are not
a good student,
you cannot
compete
with
another
student from another university. Okay. Yeah.
Again,
try to study hard. Read lectures.
Attend the lecture.
Read textbooks.
Exercise.
Do homework.
To discuss
with
your classmates.
Blah blah blah. Okay.
Yeah. So if you think
you cannot follow ECE, please apply document to transfer another program.
Okay.
Yeah.
You understand?
Yeah.
And in
VGU's own programs are mostly difficult. Okay.
Maybe you
transfer another program also difficult for you. Okay.
Try to study
hard and then
say no
with
games.
Okay.
And remember
to do exercise every morning.
Just to
run around.
Wake up
early
and run around.
Stadium.
Which is stadium. Okay. Enjoy
big breakfast.
Okay.
And then go to class.
Okay. So
continue.
What is this?
Determine whether each set is a subspace of I3.
Okay. Now we have
this set with x1, x2, and 1.
Okay.
x1 and x2 are real numbers.
This one
is not subset.
3 is not
subspace
of R3. Why?
Because,
for example, we have vector 0.
Because, for example, we have vector 0.
So if we have C,
times vector 0, we should get vector 0.
Right? But now,
if we have C times vector 0, G is 0, 0, 0.
But this one,
you get what? You get
1. Right?
1. Right?
You get 1.
Right?
Actually, this one
must be 0.
So that means
this assumes
is not satisfied. Okay.
Okay.
So we
say W is not a subspace of R3.
How about this one?
How about this one?
How about this one?
How about this one?
Yes.
Yes.
Yes. Right?
Yes. Right? Yes.
Why we say yes?
Why we say yes?
This is R3.
This is R3, right? That means every vectors will have 3 dimensions.
So if we have
vector U, we have U1, U2, and
U3.
U3.
We have vector V,
We have vector V, we have V1, V2, and V3. So if we have U plus V,
you get what?
you get what?
Here.
Here.
You get
U1 plus V1.
And then
V1 plus V2 plus U1 plus U2 because you need to follow this set, you know.
X1
plus X3.
That means
U1 plus U3, V1 plus V3.
Do you understand?
Do you understand?
And then the last element
is X3. The last element, this is X3. So when we take U plus V, you get U3 plus V3. Right? So this one belongs to R3. Right? 1, 2, 3.
Okay.
Okay.
Now C
times V.
C times V,
you get CV1. V1 plus V2, and then CV3 belong to R3. Right?
Look, this is
a set. So if we have any vector x, we have x1, x2, and x3, right?
And if we
apply this success, you can get x1 and then x1 plus x3 and then x3.
Right? So
now we have C times V.
That means
C times V1, V2, V3. And then we apply for this success, you get what? CV1, right?
Comma.
And then CV1 plus V3. Right? And then the last element is CV3. So belong to R3.
Okay. So
W is subset of R3.
Do you understand?
Do you understand?
Pretty easy, you know.
Pretty easy, They give us
the
subset W.
Okay.
Now continue. We have vector space R3.
Right, R3.
And they give us the subset
W.
The subset W is the set of all vectors of what? A, B, A plus B.
Right?
Yeah, A plus B.
So this one
is the subset, right?
Because for
every vector we have 3 elements. How many elements? A, B, and A plus B have 3 elements.
So this one is a set. So if we have vector U,
you have U1, U2, and U3.
Right. So I
would like to indicate vector U to become the column vector. We can get vector U is U1, U2, and U3 like this.
Okay. So this
is a set.
Okay, so we
demonstrate the subset W in the space.
Okay,
so now we define vector U A1, B1, A1 plus B1, vector V, A2, B2, blah blah blah.
And then if we
check SM1, this is SM1, right?
So A
plus V, you get this one. How many elements? 1, 2, and 3. So this belong to R3.
Okay.
And then we have C times A1, B1, blah blah. You get this one. How many elements? 1, 2, 3 belong to R3. So this is a space.
Okay.
Of course, we need to double check SM 2, 3, 4, 5, 7, 8, 9, 10.
But normally
if SM1 and SM6 are satisfied, the other SM will be satisfied. Okay.
You understand? Any questions so far?
Okay.
Exercise.
Now we have some exercise.
For example,
verify that W is a subspace of V.
V is
R4, right?
from.
or from.
So this is a
So
space
this is
or
a space or
not.
not.
This is a space.
This is a space or not.
This is a space.
This is a space. This is a space. Why?
Is that right?
Is that right?
Okay.
Okay.
This one is a
This
space.
one is a
or
space or
not a space.
not a space.
Very easy, right?
Very easy, right?
Yes.
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 Okay.
Yes. Okay.
So,
yeah.
Continue.
Continue.
Let
W be the set of all three and three matrices of the form blah blah. Okay. Demonstrate that W is a space of
three and
three matrices.
And this is one.
And this is one sum of
this one is
some kinds of reference answers.
For example, we
can analyze this one to become the linear combination, right?
The linear
The
combination.
linear combination.
So if
we can indicate any vectors in the set to be a linear combination in this one. So this one is a space. Okay.
Or you can
demonstrate like this. We have vector u. We have vector u. We have vector u is a1 0 b1 0 c1 0 d1 0 e1, and we have vector v.
Right.
Yeah.
Right.
Matrix v.
And then we
demonstrate SM1 and SM6. That's okay.
Or we just
indicate the linear combination.
That's
also okay. Okay, linear combination.
Yeah. So each
W is a space of M22. Yes or no?
Yes. Okay.
Yeah,
because
they give us this condition. If we don't have this condition,
okay. We need to double check.
We need to consider A, B, C, D, blah blah blah. Okay.
Maybe if here
D is one, problem.
Okay.
Anyway, it's easy. Okay.
Then symbols
for the final exam. Okay.
I
give you the vector space.
These
are three. Yeah.
I
also give you vector v1, vector v2, vector v3. Of course, vector v1, vector v2, and vector v2 belong to R3. Okay.
So
we have vector v, the linear combination of v1, v2, and v3. If we can find the real number of a1, a2, and a3, so that blah blah blah. Okay. Yeah.
So that means
this one must be consistent, right? Consistent.
Right? That means
we have a certain values of a1, a2, a3. Okay, very easy.
Then
which of the following vectors in R3 are linear combination of blah blah blah. Okay. Yeah.
So
very easy, right?
We need to verify
one must be equal to what? Equal to A times vector v1 plus B times vector v2 plus C times vector v3.
Okay,
and then you can get
augmented matrix, right? Okay, you can get what? 4.
Okay, you can get what? 4, 2 minus 3, 2, 1 minus 2, minus 2, minus 1, 0, and 1, 1, 1. Right?
This one is augmented matrix.
This one is augmented matrix, right? And then we can apply Gauss,
Jordan limits on Gauss
elimination.
And then
Okay? And then if we can get A, B, C, that means we have the solution. Okay? And then you conclude that.
And similarly, we have the vectors.
And similarly, we have the vector space alpha.
Now, number 3.
Section number 3.
We
discuss about spanning set
and
linear independence. Okay.
What is the spanning
What
set?
is the spanning set? Okay.
Of course, we know
how can demonstrate
how can
demonstrate the linear independent or dependent, right? We need to consider homogeneous systems. Okay. And if we have trivial solution, we have linearly independent. Okay. So if we have many solutions or non-trivial solution, this is linear dependent. Okay. Yeah. Yeah.
We have vector
space V.
We have
vector space V.
Okay. So any
vector V
in the
vector space capital V
is the
linear combination of the vector U1, U2, blah blah UK.
Okay, so we can
get the linear combination, right?
So now
if we have
this
set S.
So now
we have this set with vector, right? This is one face. This is vector W1, W2, blah blah, WR.
Okay,
is a non-empty set of vectors. Then the set W. Here we say the set W
of all
possible linear combination of the vectors in S is a space. Okay, so here this is maybe this one.
So
if we have this set W, okay. That's a W. Or how can I say?
Maybe
V1. V2, blah blah blah. VR. Okay. Yeah.
Of
all possible linear combination of the vectors in S. So V1 is we can indicate V1 is the linear combination of all vectors in the
S.
So A1 W1, right? But A2 W2 plus blah 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 plus AR WR.
Okay, so
all possible linear combination, okay, to become this space of vectors vector space V. Okay. Yeah.
Then
the set W in part A is the smallest space of V that contain all the vectors in S. In the sense that any other space that contain those vectors contains W. Okay.
Maybe it's
a little bit complicated to understand, but we have example. Now look.
We have
vector space V
is
R3. That means every vector we have 3 elements, right? So now we have the set S. We have vector V1, vector V2, and vector V3, right? This is S.
Okay. We
would like to consider the space like this, the set W of all possible linear combination of the vectors in S is a space of V. Okay. Yeah.
So now
we have any vector V, so V1. So we find out V1 is
3
to V2 plus V3. Right?
Yeah.
Yeah.
So
on
possible linear
combination of
V1 and
V1
V2
and V2 will become the subspace. Okay.
So here this
is the vector space.
Okay, we have S.
Okay,
so
we can find out V1 is the linear combination of
V2,
V2, V3, V4, blah blah blah. Okay.
Yeah, so you can
find the subspace.
Write
the vector W
is
a linear combination of vector in the set S. Okay,
we
need to demonstrate vector W is C1 times V1 plus C2 times V2 plus C3 times V3. Okay, this is a consistent. Okay, now look.
Okay,
1 equal to C1 times V1, C2 times V2, C3 times V3. Okay, you can get this element, this element, this C1 minus C3 is 1, 2C1 plus C2 is 1 also, in this one. Okay, and then you can get augmented matrix.
Okay.
Okay. So when we get augmented matrix, you can see this one is C1, this column for C2, and this column for C3. So C3 is C3 is what?
It's random, right?
It's random, right?
Random.
So we say C3 is a T.
So you get C2.
So you get C2 is what? C2
plus
2 C3 is a minus 1. So you get C2 is minus 1 minus 2T. Right?
And this one
you get C1
minus
C3
is 1.
Is 1. So you can get C1 is T
plus
1. Okay. Yeah.
So
it's random for us to choose T. For example, we assume that T is 1, so you can get C1 is 2, C2 is minus 3, and C3 is 1, so you get linear combination.
Or
we can say we have this subspace, right? What is the subspace? The subspace W is 1 minus T. What else? Minus 1 minus 2T and T. This is subspace.
You understand?
Yeah, here.
Okay.
Yeah. So now we have the definition of a spanning set
of
vector space. Okay.
3 minutes.
Try to understand this definition.
3 minutes now.
3 minutes now, please.
Okay,
so now we have the vector space, right? We have the vector space.
the vector space
EV with Rn dimension.
We don't know.
We don't know, maybe n dimension.
And then we subset S.
How the
Contains how many vectors?
set
K vectors.
S
Okay. Whether we
contains
blah blah blah.
how many vectors K vectors.
We don't know how many vectors.
Okay. Whether we
know
want
it is a set. And every vector V1 we have V1 1.
We don't know how many vectors.
V1 2,
but
blah,
we know
blah,
this is
V1
V1 2
right?
blah 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 V1
vectors by Rn, so every
right?
vector
Because we have vectors by Rn, so every vector we have n dimension.
Okay.
N element.
Yes.
Okay.
So now
Yes.
if I
pick up randomly vector W
belonging to
Rn.
So that means
W we have W1 blah 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 W n.
Right? So
if I can indicate vector W is C1 times
V1
V1 plus C2 times V2 blah 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 CK times VK.
So we say
S a spanning set. Okay. Yeah. Or we can say S is a spanning set if and only if we have linear combination. Or this one is consistent. Right? This one is consistent.
Okay. We say
S is a spanning set, or we say S span V. Vietnamese S là mở rộng. Okay. S là mở rộng của V.
Yeah.
So now the question for you.
We know such
space, right? We know such space.
We
know spanning set. So a space is a spanning set.
Yes or no?
Yes or no?
And
a spanning set is a space.
Yes or no?
Yes or no?
Okay, yeah.
Now think carefully.
Think
carefully, okay?
Okay, so now
we know spanning sets, right? Spanning sets. So the spanning sets mean any vectors in vector space V can indicate by the linear combination of all vectors in S. We say spanning set. Okay. To the questions.
The
subspace is a spanning set.
Yes or no?
Yes or no?
And
spanning set is a subspace. Yes or no? Okay. Yeah.
So
the first sentence. The subspace is a spanning set.
Yes or no?
Yes or no?
Yes. Of course.
Of course. You will say yes. Right?
Okay.
So spanning set is a subspace. Yes or no? Sometimes. Okay, not always.
You know?
Because if we say spanning set is a subspace, you need to demonstrate 10 axioms. 10 axioms. 1, 2, 3, 4, 5, 6, 7, and 10. Okay.
So
maybe spanning set is a subspace if they satisfy 10 property, 10 axioms. Okay? 5 property for vector addition and the other 5 property for
a scalar
multiplication. But we know if we have such space, of course, this is spanning set. Right?
Understand?
Yes.
Is it clear for you?
They use ChatGPT.
Okay.
Like this, like this,
We have
the lines prove the origin, right? The lines origin. Okay. Yeah.
So this one
So
is
this one is Spanish set.
Spanish set.
This is Spanish set, right? It's Spanish.
And we have
a blend
goes
goes
through
through the origins.
okay, determines by
Determines by V1 and V2. So we have this Spanish set. Okay, Spanish set. Okay. Yeah.
Example. We have vector space V is R3.
Vector space V is
and
R3.
we have Spanish
VCR3 and we
how many
have Spanish
vectors?
set.
Three.
How many vectors? Sorry, not
How many
Spanish
vectors
set.
of
This set.
this set?
So how many vectors
One,
of this set?
Two,
One,
three.
two,
Okay, so
three.
we say V1.
Okay, so we say V1,
and
V2, and V3.
Okay, this is
Okay,
V1.
this is V1.
This one is V2.
This one is V2. This one is V3.
So if we can
demonstrate any vector U
belonging
to vector space R3,
E the
linear combination of
V1,
V1, V2, V3, we say S is Spanish set.
Okay.
Okay. Then look.
What is it?
What is it?
This is
a standard unit vector, right? Unit.
So now
any vector U, we can get the linear combination of standard unit vector, right?
Okay,
so this one is Spanish set.
So how about this one? This one is also
Spanish set. Why?
Because
we
have B2.
B2 show like this format, right? A plus bx plus x squared. Okay.
So if I say
A times 1 plus B times x plus C times x squared, how many vectors we have? 1, 2, 3. 3 vectors.
Okay.
3 vectors.
Right. So
any bx we can get A times 1 plus B times x plus C times x squared. This is a linear combination.
This is linear combination
of 3 vectors, vector 1, vector x, and vector x squared. Different vectors, not elements, right?
Because this is
set S.
The set S
contains many vectors. So this one like vectors.
Do you understand? Do you know?
Every vectors how many elements? One element.
One x or x.
Okay. Yeah.
But here.
Any vectors how many elements? 3. Okay.
So this set
is a Spanish set.
Yes or no? Okay. So now any vector U belong to R3.
You can get vector U is C1. For example, this one is
V1,
V2, V3, right?
So we can get
C1 times V1 plus C2 times V2 plus C3 times V3.
You can get what?
C1 times 1, 2, 3 plus C2
0,
1, 2 and C3
minus
2, 0, 1, right?
Yeah. So you can get
coefficient matrix.
Coefficient
matrix, right? Coefficient matrix is what? 1,
2, 3,
0, 1, 2, minus 2, 0, 1. Yes. So we can find out C1, C2, and C3 if determinant of I, for example, here is different from 0, right?
We study
determinant from lecture 2. And if determinant is 0, that means no solution.
Right?
So here we don't care about what's in the unit vector. What's in the vector V, vector U.
We just
demonstrate this one is consistent.
That means we can
indicate U to become the linear combination.
How can we do that?
How can we do that? We calculate determinant.
Different with 0.
Different with 0. That means it's inconsistent, right?
Okay, and then
we say SA Spanish set.
Right?
Is it clear for you? Okay.
Any questions? Females, students, any questions? No questions? No question mean understanding, right? No question mean understanding. Hỏi nó câu hỏi nào nó cũng lắc đầu. Hỏi nó câu hỏi nào nó cũng lắc đầu. Cũng lắc đầu. Vậy phải. What do you mean? Cũng lắc đầu. What do you mean? Any questions? Any questions? Đi nhanh mấy đứa à? Trái giáo án quá.
Chắc mình phải đi nhanh mấy đứa à? Trái giáo án quá lâu, quá nhiều rồi. Giờ để coi.
I just take a look and
maybe we need to skip some.
Show off.
Continue.
Maybe one more
example, and then we can stop. We can now 3:52.
So
determine whether the vectors v1,
vector
v2, vector v3 spans vector space R3.
Okay.
So that means we say we have the set S to contain v1, v2, and v3, right?
And then
any vector B belong to vector space R3
to be
the linear combination of V1, V2, and V3. Okay, so we have vector B is C1 times V1 plus C2 times V2 plus C3 times V3. Here they don't use C1, C2, C3. They use K1, K2, K3. That's okay. Okay, so we can get coefficient matrix, right? Coefficient matrix, and then we can calculate determinant. Okay, determinant of A is what?
We choose this one.
We choose maybe it's this one. Okay, you can get 1 times what? 0, 1, 1, 3. Okay, plus what? Minus 1, right?
1, 2,
1, 3. Plus 2, 1, 2, 0, 1. How many? This one is
minus 1,
right?
This one is
what?
3. Minus
2 is 1. So you get here is minus 1, right? Plus. Then here you get what? 2.
Okay.
So minus 1, minus 2 plus 2 is 0, right? The determinant is 0. So that means this one is inconsistent. Okay? Inconsistent. So we can say that.
We can say that.
Okay. We
trong
hao any spanning set containing V1, V2, and V3. Okay.
Yeah. Because
it is
non-consistent.
Okay.
Here we have
the set S1,
the set
S2. Okay.
The question for you.
Show S1 is a spanning set, or S2 is a spanning set, and why? Okay. Come back. So if we have vector B is the linear combination of C1, V1 plus C2, V2 plus C3, V3. We say B is the linear combination of V1, V2, and V3, or we can say V1, V2, and V3 are linearly independent.
Is that right?
Is that right? independent.
So
here, look at this one.
Look at
this one. No.
Yeah. The vectors
in S1 trong line common plane. Okay. So
that means
they are
independent.
They're independent, right? They're independent.
So if they are
independent, we can get this is Spanish set. So S1 is a Spanish set. Because all vectors of
S1s
are linearly independent.
But
now look at this one. S2 doesn't.
Why? Because
linearly
dependent.
Okay.
So
if we have linear dependent, we can get linear combination.
Okay.
So we say X2 is not Spanish set.
Okay. So we have two ways.
Okay. You can get determinant, and then you demonstrate determinant of coefficient matrix is different from 0. So we say S is Spanish set. Otherwise, we need to demonstrate
all
vectors of the Spanish set are linearly independent. Okay. So S is also Spanish set. Yeah.
Okay.
So here. Just review the what's in the Spanish set, right? Any vectors of the vector space can be expressed by linear combination of all vectors of the set S. Okay, we say Spanish set or S space V. Okay, so space S is a space of V. If blah blah blah. Okay, if this one is a set of vectors in the vector space, then space S is a space of V. Okay. So space S is the smallest space V. Blah blah. Okay. Read this one for yourself. Okay. So yeah.
Here look
for. Spanish says S is a space of vector space V.
And
is it right? Is it right? Let me check. This.
Maybe I
need to double check this one. Okay. Let me see this. The Spanish set S is a space of vector space V. Okay.
Anyway, I
need to double check it. Is give you explanation next lecture. Okay. So we have procedures for identifying Spanish set. Okay.
So first of all,
we need to understand the set S. Okay.
And then we can demonstrate any
vectors of vector space in the linear combination of one vectors in the subset S. Okay. Or we can calculate determinant if determinant is different from 0. This is consistent and this is Spanish set. Okay.
Maybe we
stop now. Slides 55. Okay. And next week we continue.